And then I just calculated today that, in fact, 3i Atlas gets near Jupiter on March 16th, 2026, at a distance which is exactly identical to the distance inside of which Jupiter's gravity dominates over the sun's gravity. And this coincidence is to within 1 part in 26,000. Quite amazing. It's remarkably exactly the right distance for Jupiter's gravity to dominate when 3 Atlas comes closest to it. And in fact, the non-gravitational acceleration that was reported after it came closest to the sun, there was some push that was noticed in its trajectory, some slight deviation from the original path is needed in order to bring it exactly to that location. So by now I have even more puzzles, and the fact that NASA ignores the anomalies that 3 Atlas had, meaning the very small likelihood that it lies in the plane of the planets around the sun, and its very large size, 1,000,000 times more massive object than the first interstellar object, obviously allows them to make a very confident statement that it's a comet, but I'm still very intrigued by these anomalies.
Wow.
After 12 perplexing mysteries, 3i Atlas has now delivered its most astonishing anomaly yet. Recent trajectory analysis revealed a non-gravitational acceleration that altered its path near Jupiter with remarkable precision. The adjustment shifted its closest approach to align exactly with the outer boundary of Jupiter's Hill sphere, the region where Jupiter's gravitational pull becomes equal to the Sun's. Without this acceleration, models show that 3i Atlas would have passed completely outside that limit. No natural forces, such as irregular outgassing or solar radiation pressure, do not account for a course change this narrowly tuned. This is the point where the data becomes difficult to dismiss as coincidence. The object's trajectory didn't just shift, it shifted to a very specific gravitational threshold, one with no obvious reason to be targeted by a natural comet. Either there is a precise physical mechanism at work that we do not yet understand, or 3i Atlas is responding to its surroundings in a way that defies standard comet behavior. With this 13th anomaly, the situation becomes more unsettling. If the motion is not random, then we must ask what or who is driving it. For months, astronomers have been documenting unusual behavior from this object. Some of these anomalies seemed small at first, odd perhaps, but not impossible. It fragmented earlier and more aggressively than expected, shedding material that should have slowed it down much more than it actually did. Its brightness fluctuated in patterns that did not match any predictable rotation or thermal cycle. The dust and gas surrounding it behaved inconsistently with sunlight as the primary force acting upon it. And then came a sequence of jet anomalies, including one jet that appeared to aim toward the sun and maintain that direction far longer than jet physics should allow. That earlier jet already raised concerns because sunlight causes heating. Heating causes outgassing, and outgassing typically produces jets that face away from the sun's direction, not toward it. But some researchers held out hope that geometry or imaging angle might have misled observers. Then NASA released new images taken not from Earth, but from the Mars Reconnaissance Orbiter. Those images revealed an entirely different perspective, and a much more troubling one. Seen from the vantage point of Mars, the jet that previously appeared sunward was revealed to be actually pointing almost perfectly perpendicular to the sun's direction, at a clean right angle. This configuration is not only unexpected, it should be impossible. Solar heating forces jets to erupt from areas facing the sun. Radiation pressure and the solar wind then push dust and gas away from the sun. Every major force acting on a comet points either toward or away from that star. And yet 3i Atlas maintains a jet aimed 90 degrees off this axis, forming a long straight column that shows no evidence of curvature.
If rotation were swinging a jet sideways, the material would trace a spiral. If random outgassing were responsible, the direction would constantly shift. Instead, the jet appears locked in orientation, held steady even as the object rotates with a measured period of about 16 hours. This implies that the source of the jet remains fixed relative to the sun, not to the object itself, a scenario that makes no physical sense for a body tumbling freely through space. There is no known natural mechanism that can maintain such a stable, perpendicular ejection of material over such a large spatial scale and over time. In other circumstances, each problem might have been explained away as observational bias, timing, or simply a lack of data. But with each new observation, explanations that might have once seemed viable are now eroding. A pattern has begun to emerge, one that suggests something more systematic is happening than random comet physics. The course correction toward Jupiter's Hill sphere is the most alarming development because it involves navigation relative to large-scale gravitational structures, not just changes in brightness or jets. Jupiter's Hill sphere is enormous, around 53 million kilometers in radius, but despite that size, the difference between reaching its boundary and missing it is not trivial. If 3I Atlas had arrived a little too far on the outside, Jupiter's gravity would have had essentially no effect on it. If it had gone deeper within the boundary, the planet's pole could have significantly altered its path, slowing it or even trapping fragments temporarily. It did neither. Instead, it arrived at the mathematical edge, a point where influence begins, but capture does not occur. It is a razor-thin line. Hitting it requires accuracy, and accuracy requires either an improbable stroke of luck or a force guided by something more than random comet behavior. This situation invites comparisons to the first interstellar object humans ever detected, 1I Oumuamua. That object also exhibited a non-gravitational acceleration that defied comet models, yet displayed no signs of outgassing whatsoever. It behaved as if being pushed by some internal or structural mechanism, something more akin to light sail physics than traditional solar heating. That event generated controversy, scientific debate, and eventually a conclusion that we lacked sufficient data to draw definitive answers before Oumuamua disappeared from view forever. 2I Borisov, the next interstellar arrival, seemed far more ordinary, an ice-rich comet consistent with expectations. That gave some a sense of relief. Perhaps Oumuamua was just an oddball. But now, 3I Atlas has arrived with a new set of anomalies, behavior unlike Oumuamua or Borisov, and unlike any comet ever studied in recorded history. If these objects represent a category, not an exception, then the simple space rock interpretation may no longer be tenable.
Some astronomers propose the possibility of exotic types of outgassing, materials we have not seen up close sublimating differently under solar irradiation. Others point to potential measurement errors that might be corrected with more observations. Such caution is appropriate in science, but the accumulation of evidence is shifting the tone. When a pattern begins to form, a pattern that consistently contradicts our physical assumptions, the argument that nature is weird becomes less satisfying without a specific mechanism. This brings us to a more difficult topic, the technological hypothesis. Astrophysicist Avi Loeb has been the most vocal figure in arguing that the scientific community should not rule out the possibility that some interstellar objects might represent technological artifacts, whether defunct equipment, exploratory probes, or remnants of an advanced civilization's activity. His position does not claim certainty that such objects are artificial, but emphasizes that unusual behavior, when unsupported by existing natural models, should be evaluated without bias. Loeb frequently highlights that dismissing a technological explanation without fully examining the evidence reflects sociological pressure within science, rather than a conclusion drawn from data. In his view, scientific inquiry should follow the anomalies wherever they lead, even if the destination challenges long-held assumptions. In the case of 3I Atlas, the concern stems from specific observational results rather than speculation. The recorded trajectory change occurred with a degree of precision that known comet physics struggles to reproduce. Outgassing events typically generate irregular, time-variable forces and result in noisy accelerations, often producing rotations or curved jets, not finely tuned alterations that match a critical gravitational boundary. Loeb points out that a slight misalignment would have produced a noticeably different outcome, a missed influence if too far outward, or a deeper gravitational deflection if too far inward. The match instead falls within a narrow tolerance band that does not appear accidental within current modeling. His comparison to spacecraft navigation is grounded in established engineering practices. When mission planners send probes through planetary systems, gravity assist maneuvers and boundary sampling of gravitational spheres are commonly used to map gravitational fields, minimize propellant usage, and achieve long-distance travel. These maneuvers involve calculating where gravitational influences balance, the same kind of location that 3I Atlas intersected near Jupiter. A probe designed to collect data on planetary mass distributions or to test navigational capabilities might execute such a calibrated approach. Loeb's stance is that the absence of a verified natural mechanism leaves room for a technological hypothesis. not as a conclusion, but as a testable option. If future observations reveal additional precise course changes or consistent interactions with gravitational thresholds, the argument for non-natural dynamics would strengthen. Conversely, identifying a new physical process capable of producing such controlled effects would provide a natural explanation. Either outcome advances scientific understanding. For that reason, Loeb asserts that exploring the full range of hypotheses is not sensationalism. It is responsible science, especially when confronted with behavior that defies existing models.
Planetary defense experts are quietly paying closer attention as well. If something can navigate gravitational boundaries with precision, then Earth's defensive assumptions need to evolve. Humanity's monitoring of near-Earth objects is based on tracking and predicting natural trajectories, ones governed by gravity and sunlight alone. A visitor that adjusts its path actively could evade detection or alter its route unpredictably. Even if harmless, the precedent itself changes the rules. As 13I Atlas continues its journey, the window to study it is narrowing. It is moving rapidly through the inner solar system and will soon head back into interstellar space, beyond the reach of most of our instruments. Once it leaves, the opportunity to gather direct evidence, spectroscopic signatures, detailed imaging, sharper 3D trajectory mapping will be gone. This urgency is prompting discussions about rapid response missions in the future, spacecraft that could intercept unknown visitors quickly rather than miss them as we did with Oumuamua. There is also a philosophical weight settling in. Humanity has long suspected that life must exist elsewhere, statistically speaking, but most expected first contact, if it ever came, to be unmistakable. A signal, a structure, a message. Few imagined the first sign might take the form of objects that sneak through quietly, leaving only physics itself to betray their unusual nature. The question now is not whether 3I Atlas is artificial. That remains unproven. The question is how many more anomalies must be observed before we conclude that we are witnessing something unfamiliar not by coincidence, but by design. If precision adjustments continue to appear, if jet directions remain inexplicable, if future interstellar objects show similar traits, then we will be forced to rewrite our assumptions about what travels between stars and why. For now, 3I Atlas continues forward. It has shown us a behavior that pushes the limits of natural explanation. It has revealed that current physics does not fully describe what is happening. It has demonstrated responsiveness to gravitational structures that we would normally attribute only to controlled flight. Each fragment, each jet, each shift seems to point toward a mechanism that is operating with a goal, one we do not yet understand. Maybe a new natural process will be discovered that resolves everything cleanly. Science would welcome that outcome. But until such a mechanism is identified and verified, the 13th anomaly of 3I Atlas will remain a visible crack in our certainty, a reminder that something out there is capable of navigating the cosmos with precision we have yet to explain. And perhaps the most unsettling part is this: if 3I Atlas is not acting alone, then the universe may be far more active than we ever imagined. It's not the unknown that creates the fear. It's the possibility that the unknown is already here, moving with intent through the dark, while we are only just beginning to notice.